Uh, this lecture, today's lecture, this is a small video I'm preparing for associative memories. Okay. So first, going through the introductory part of the associative memories. So when we normally when we speak about memories, it's like there is some chip, physical chip, okay? And then that physical chip is divided into number of locations, and each location is given an address, say 0, 1, 2, 3, 4, 5, and so on. Then we have a computer, or I can say a processor. Yeah. This microprocessor gives the address to the memory chip. There, say it is giving address 2. Say the data stored on these locations are say 5, 6, A, F, E, C. Assume. Okay. Then your microprocessor gives the address, say 2. Then it gives a command to this chip called as read, and then there is a bidirectional data bus here, which can read as well as write depending on the condition given on the command signal. Now, since our address is 2, our execution will reach this second address, and since the command is read, this A, which is the content of 2, will be delivered to memory location, delivered to the processor. Okay, this is regular memory. These are called as addressable memories. Okay, when we have a tool of neural network, we can design another form of memory. We call it as content addressable memory. Here, content addressable memories. So this is designed based on neural networks. What is the difference between this memory that is content addressable and address addressable? In content addressable memory, we don't give addresses, we give the content to the memory. Clear? We give the content. This content may be having damaged or missing data. Okay. The content may be not exactly in the form, there's damaged or missing data. And in return, my memory gives me the correct data. Here, so I didn't address the memory location. I gave the content. Memory matched that damaged content with one which is closest matching one of the stored contents, and then it gives the correct content. So we address the memory using the content, not using the address. Okay? That's why it is called as content addressable memories, and that is designed using neural networks. This is the fundamental difference between addressable memory and content addressable memory. So now we are interested to treat this a bit in detail. Yeah. So these are the all description of what I just told you. Now, content addressable memories. When I say content addressable memories, they are of two types. Here, one is called as auto associative, and one is called as hetero associative. Now, when I say auto associative memories, what happens is that there is memory chip same, not maybe chip, maybe I designed it as a neural network model. Okay, so I give one pattern to this here, that is called as key pattern, मतलब जो identify करने के लिए देते हैं, and it gives me the actual pattern. Clear? तो ये जो की पैटर्न है और ये जो रिटर्न पैटर्न है, इफ दे आर सेम, मतलब मैंने समझो आई गेव अ डैमेज फोटोग्राफ एंड आई गेट अ करेक्टेड फोटोग्राफ. then input and output have same form. We call it as auto-associative. Hetero-associative, what we do, the key pattern and the actual pattern are different, or generated pattern are different. Key pattern, assume I am giving as fingerprint. Clear? Assume that. Yeah. Key pattern is separate. Say I am giving key pattern as fingerprint. Okay. And in return, I get the identity of the person. So key pattern and return pattern are different. Structure memory is called as hetero-associative memory. Yeah. There is a special case of hetero-associative memory also. Like we give key pattern and we get identity, or other way, we give identity and we get key. Means the network works both ways. So that is a special case of hetero-associative memory. It is called as bidirectional associative memory. Okay, so it is a special case. We are going to treat it separately in this chapter. So let's move on. So moving to the first type of associative memory, that is called as auto-associative memory. Clear? Auto-associative, as I told you, the training and the target vectors are similar in nature. So discrimination of weights of the association is called storing of vectors. Yeah. तो जब भी इनपुट वेक्टर हम लोग का क्वाइट सिमिलर रहेगा, मींस इनपुट वेक्टर is quite similar to one of the patterns, it will return the corrected pattern to us. Okay. So performance we can measure using the ability to reproduce the correct pattern, correct stored pattern from the noisy input. Yeah. Abhi, this is a neural network, so it will have a weight matrix, right? वेट मैट्रिक्स में अगर हम लोग ने सारे डायगोनल एलिमेंट जीरो किए, we call this as weight matrix with no self connection, or associative network with no self connection. And ये without self connection वाला architecture is going to improve the stability, like its accuracy of the net. It will increase the generalizing ability. Generalizing ability मतलब क्या होता है? See, uh, just a minute, I'm going to generalization. When I teach, suppose there is a child here, इसको मैंने bottles दिया, अलग अलग टाइप के bottles, bottle 1, bottle 2, bottle 3. इसने ये bottles देखे और इसने समझा कि बॉटल को आइडेंटिफाई कैसे करने का. Now if I give another, say, different type of bottle, very different type, समझो ये वाला bottle was of cold drinks, ये अपना कॉलेज में वगैरह लेके जाते वैसा स्टील का बॉटल, ये थर्मोस फ्लास्क जैसा था. तो दिस वर डिफरेंट टाइप्स ऑफ बॉटल. मैंने अब इसको अलग ही टाइप का बॉटल दिया, बॉटल एक्स, हैप्पी फिश का बॉटल, जो इसका शेप थोड़ा अलग रहता है. या सो आई गिव दिस पर्सन दिस हैप्पी फिश बॉटल. तो अगर ये हैप्पी फिश को देख के जनरल कंसेप्ट समझता है कि मतलब देयर इज अ कंटेनर एंड देयर इज अ कैप, समथिंग फिल्ड, तो इसको जनरलाइजेशन बोलते हैं. मतलब तीन बॉटल देख के इसने ये सीखा कि बॉटल में क्या होता है, एक सिलेंड्रिकल स्ट्रक्चर, कैप एंड समथिंग फिल्ड, ये ऐसा कुछ रहता है. तो ये उसने सीखा, इसको जनरलाइजेशन बोलते हैं. तो इसको हैप्पी फिश का बोतल दिया तो भी ये समझेगा कि दिस इज बॉटल. इफ इट डजंट जनरलाइज, तो इसको हमेशा बॉटल 1 2 3 दिया तो आइडेंटिफाई कर पाएगा. बट इफ यू गिव दिस डिफरेंट टाइप ऑफ बॉटल, he will not be able to identify. This is called non-generalized model. So we always desire जितने examples अपन देते हैं उतना the model should become generalized. Yeah. So if we make the diagonal weight 0, the auto-associative network can better generalize. So I wanted to say. Okay? So neural networks generalization is very, very important. Coming to the architecture, so architecture is shown here. Here, remember input and output are similar. So input is x1, x2, dash 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 till xn. Similarly, output will also be y1, y2, dash 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 yn. मतलब जितना input nodes उतना output nodes. Clear? So that is one of the important characteristics. This we give as the test pattern, and this comes out as the response pattern. Okay? तो पहले हम लोग लेबल करके देंगे. लेबल करने का जरूरत नहीं, मतलब you have to keep this as input and this only as a target. Auto associative है ना, मतलब इसने ये input दिया तो x1 ideally should be equal to y1, x2 should be equal to y2, and so on till xn equal to yn. तब तक we have to train the weights. Clear? अभी इधर हम लोग बहुत सारे इसको weights देने वाले. Okay, we are going to give it lots of samples. इसके weights will go on generalizing. So, उसके बाद अगर मैंने कोई डैमेज पैटर्न इधर किया, it should generate a known one of the stored patterns which is closely related to this damage pattern for me at the output. Yeah, so that is called as auto association. Yeah. So architecture wise, the training and target input vectors are same. This is very important. The training and target are same. मतलब auto associative के क्वेश्चन में तुमको टारगेट नहीं देंगे, सिर्फ maybe they will give the design a auto associative network which can store this pattern 1110. So this is your x and this is only your t also. Yep. So that way you have to remember. Yeah. मतलब training vector will not be given separately to you. Only if you see the name auto associative, immediately you should understand that x is equal to t. Yeah. Then input and output are connected through weighted connections because this is a neural network and vectors are perfectly correlated with each other, component by component. So x का समझो x1, x2, x3 रहेगा input. इसका जो y रहेगा that will also be very very similar to x1, x2 and x3. Here because input is same as output. That is all about the architecture. This is architecture. The training algorithm, normally we use the Hebbian learning for associative memories. Yeah. We initialize the weights. We initialize the weights for each input pattern. We may not be given T, might be we will be only provided with S because S is equal to T. Clear? So see, we activate the inputs as SI and output also as SI and update the weights using the Hebbian learning rule. So एक ही iteration होगा. Clear? It will not be going on checking any stopping condition. जितना भी sample रहेगा उनके लिए it will update the weight once and it will generate a final weight matrix. That is all about the flowchart. Here, please understand that this is nothing but the Hebbian rule. Here, moving ahead, let's solve the problem to better understand how this associative network. The question says we have to train an auto-associative network for input vector -1, 1, 1 and you have to test the network for same vector. मतलब इसके ये यूज करके अपने को नेटवर्क बनाना है एंड टू चेक वेदर अगर मैंने ये इनपुट दिया तो यही आउटपुट देता है कि नहीं. दिस इज आइडियल टेस्टिंग. देन सेकेंड पार्ट ऑफ द क्वेश्चन सेज यू हैव टू टेस्ट दिस नेटवर्क विथ वन मिसिंग एंट्री. वन मिसिंग मतलब कोई भी एक जगह पे 1 या -1 जो भी है उसके यहाँ पे 0 रहेगा. मे बी दिस बिकम्स अ मिसिंग एंट्री. क्लियर? वन मिस्टेकन एंट्री. मिस्टेकन मतलब 1 becomes -1 or -1 becomes 1. Say -1 1 minus 1 1 हो गया. So you can see this third pattern 1 से minus 1 हो गया. So we call this as mistaken. So first you have to test with one missing and one mistake, and after that you have to test for two missing and two mistake also. Yeah. So this problem is very vast and it gives you essence of all the possible combinations of the associative network. Okay. So let's start. So we have been given input vector. The weight vector is given as S transpose. S means this becomes X. Clear? You can write here uh, that S is equal to X and then W S transpose into S. Actually, this is like S transpose into T. लेकिन अपना T और S are exactly same. So that's why both are S only. Clear? So let's substitute there. This is the S transpose, इसका transpose, and this is S. We multiply and we get this kind of matrix. अभी without self connection question में बोला नहीं है, so let's not make. Other question में बोला, so you have to make this 0. Okay. So this is done. एक ही sample था, तो अपना weight matrix is designed. So now let us see whether it gives same output. So same test training के लिए जो use किया था, वही we are using for testing, and we will compute the formula for y in is x dot w. Clear? So x is the input. मतलब कभी भी तुम्हारे पास न्यूरल नेटवर्क का वेट मैट्रिक्स रहेगा, you take the actual inputs dot product with the weight matrix, you'll get the y in. Okay, so when we multiply this x dot w, we substitute these values and we get this minus 4 4 4. इसको अपन एक्टिवेशन फंक्शन लगाएंगे which is given by if y in is greater than 0 then 1, it is less than or equal to 0 minus 1. Yeah. So if we apply activation function to this, then we get this. This is less than 0 minus 1 1 1 1. Yeah. And we see that it is exactly same as input pattern. मतलब हमने input pattern स्टोर किया है, मैंने इनपुट पैटर्न इसको दिया, तो ये मुझे वापस इनपुट पैटर्न दे रहा है. मतलब एटलीस्ट ट्रेनिंग सैंपल के लिए इट इज वर्किंग परफेक्ट. गॉट इट? ओके, लेट्स मूव अहेड. नाउ सेकंड पॉइंट, one missing entry. Say the first, that was minus 1 is missing. Yeah? मतलब उधर जीरो आ गया है. Let us see ये missing entry लेके whether it is able to generate the actual pattern. Yeah, let's start. So we compute regular जो भी input vector दिया है उसको लेके we take this is not minus, yeah, we take the dot product with the weight matrix which you have found and we get these values. Then you have to apply the activation function. Activation function, say you call this as 1. So applying activation function 1, we get ये less than 0 है तो minus 1, so 1, so 1, so 1. Yep. So we see that एक मिसिंग एंट्री रहेगा, फिर भी नेटवर्क वाज एबल टू सक्सेसफुली रिकंस्ट्रक्ट द पैटर्न. मतलब समझो we had a image here, some we are trained that image, sorry, the train the neural network, assume that there is some, yeah, assume that either there's a apple, okay, which is not complete, और हमने इसको ट्रेन किया है using the complete apple. Okay, so we trained it using a complete apple. Maybe one or two times we ran the algorithm. तो अभी मैंने ये इनपुट दिया, it will generate this for me. though some of the parts are missing, it will regenerate that for me. Yeah, that is a importance. So now you have to try yourself. That is, you have to find the response for this place as missing. You can see here again. This is one missing entry only. Minus one, one. This is missing and one. Can take a pause the video and do this calculations. Okay, and verify whether it is able to regenerate or not. We are moving to the next part of the question. Now we have to take uh, the output for one mistaken entry. Mistaken मतलब data change होता है. Missing मतलब data है नहीं. Mistaken मतलब data changes. Here, so you see here, ये minus one actual vector was minus one 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 one. अभी हम लोग ने एक missing sorry mistaken entry लिया. ये one has got converted into minus one. Let me see whether it converts this into this as a response. कंप्यूटिंग नेट इनपुट का सेम रूल. जो भी वेक्टर तुमको दिया है, टेक इट्स डॉट प्रोडक्ट विथ वेट मैट्रिक्स w and you get some response, and apply activation function, and you are going to get this minus 2 will become minus 1 and remaining all three will become ones. Okay, so the correct response is obtained. Again, clear. So one missing entry and one mistaken entry doesn't affect the network. मतलब around you can see इसमें चार ही डेटा है, उसमें से एक मिस्टेकन या मिसिंग, मतलब 25% ऑफ डेटा is mistaken or missing. Still, your network is able to recover that. Yeah. To verify, we can try for this. Either this minus one 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 has been converted into this, where this is mistaken entry. Minus one ka one ho gaya. You can just check whether you are getting correct response. Do it yourself. Now let's check for two missing entries. Yeah. Remember, our data was minus one 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 actual pattern stored. अभी ये दो entries are missing. Let's see. Same, we'll compute the net input using the same formula x dot w here, and we get this, and we will apply the activation function. Oh, wow. So even if 50% of data is missing, we are able to reconstruct the original pattern back. Okay, so that is the essence of this cell associative memories. Here, you can try for yourself another combination where these two data are missing. Yeah. Let's move to mistaken entries. Again, reminding our actual data is minus one 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 one, and you can see these two are missing. Not missing, mistaken. Here, ये one का minus one हो गया, ये one भी minus one हो गया. So we go by usual rule. We are going to take a dot product of x and w, and we get this, and then we apply activation function, and we get this as the response. Maybe this is one, sorry, this is positive one, and remaining all are minus one. And if you have taken activation function as greater than equal to 0 रहेगा तो 1, फिर भी it becomes plus 1 1 1. Okay, still the pattern is not recovered. So if the 50% of the data is mistaken, then our network doesn't work. Clear? So our network gave good performance, means able to reconstruct the pattern when one is missing data, then one mistaken data, then it was able to reconstruct with two missing data also, but it could not do for two mistaken data. Okay? So it was able to do for these three cases. So it may be not always working for 50% missing or mistaken data. It depends. मतलब इसमें तो हमने एक ही पैटर्न स्टोर किया है, ऐसा नॉर्मली नहीं होता. नेटवर्क में हैव मेनी पैटर्न्स, और इसके अंदर फीचर्स आर आल्सो फोर. नेटवर्क में हैव tens of features here. So we are just trying to understand how this network is useful and how it can be used for any of our applications. Yeah, that's all regarding the first problem. Can go through and have a revision of the concepts. Let's solve one more problem. Here, the thing is the difference between the earlier question and this question is that here there are two patterns. So you should know how to work with two patterns also. We have to find a weight matrix with self connection and then a weight matrix without self connection also. We have to test the network for these inputs. Clear? What response it gives for these inputs. Let us try to understand how this network is going to work. You can see this input is same as this one, and this input is same as this one. Okay? And the third one is you can say the first input with one missing bit. Yeah. So let's see how we go about this question. Have a look at the question in 2 seconds. Then pause the video and have a look at the question quickly. Okay. Moving towards solution, as usual, we are given two vectors. तो दो वेट मैट्रिक्स लेंगे इसको ऐड करेंगे. Clear? So I will take first W1. There same formula I'm using. But my S will be this first pattern. And I get this weight vector. Then I take second pattern which is given. उसका भी मैं transpose के साथ multiply करके I will get another weight vector. And then I will going to add this W1 and W2. Okay? That will be my final weight vector. So this is my final weight vector W, which I believe has memorized two patterns which are given to me. Okay. So now, as the question says, we have to test for first pattern. क्या करते हैं हम लोग? Simply we take a dot product of x and w and apply the activation function. Here, please mention the activation functions. I can say activation function. Here you mention it. F of x is equal to 1 when x is greater than 0, and f of x is equal to minus 1 when x is less than or equal to 0. Clear? And call this activation function as equation number 1, which we are going to use always. Clear? So मुझे ये मिला, and when I apply activation function 1, I get 1 1 1 1. So first input pattern my network is able to reconstruct. Yeah, memorize कर दिया. Let's check for second one. Same procedure will follow here, and then we are going to apply the activation function 1, and we are going to get minus 1 1 1 minus 1 here. And so second pattern is also correctly stored. मतलब ये जो combined weight matrix है, it is able to represent both the stored patterns at least without any mistake. Now we are moving to the one missing entry. Clear? So we'll do same way. जो भी input vector दिया है, take a dot product with weight matrix and then apply the activation function, and we get the first pattern. That is correct. This is the first pattern with one missing entry. Here, the correct response is optic. So we have done satisfied all the requirements of the problem. Okay, we tested with the first input vector, first training vector. We tested it with second training vector, and we tested with the given training vector as well. Yeah. So that is another problem we have completed on activation from association. Okay. So let's move ahead. Second part, second type of the associative memories are heteroassociative memories. As I told you in the beginning, here the input pattern, that is key pattern, and the output pattern are different in nature. Clear? Means you will give some input key pattern, say in the form of fingerprint, and I am going to get output as the identity of the person. Okay, means uh, format wise, input data and output data are different. Okay. Okay. The second type of the associative memories are hetero-associative memories. Varun is there?
Yes, sir.
Okay, okay. I thought no one is there, so I was recording for you people. You are
Uh,
not there for that exam?
no, no, sir. No exam for me today. Actually, I joined a little late, sir.
Okay, okay. So you are taken on that problem?
I couldn't take the last problem, but I'm taking the taking this problem, sir.
Last problem, if you want, I can show you. No problem. I thought no one is there. That's why I was teaching.
Uh, I'll capture it from the recording, sir. No problem.
Oh, okay, okay. Okay, fine. Yeah. So you got this definition of heteroassociative memories?
Yes, sir.
Okay. So let's move ahead. So this is about the theory part. As I told you, the training input and the target input are different. Clear? So again, network is trained to determine the weights that can store the pattern of association. So association by definition is a pair of training input target and output vector pairs. Like these are the inputs and these are the targets. Here means we have p number of inputs, so we'll have p number of targets also. So each vector has n components and इसका रिस्पॉन्स वेक्टर हैज m कंपोनेंट्स जैसे ऑटो एसोसिएटिव में इनपुट जितने न्यूरॉन से उतने ही आउटपुट में रहते हैं दैट मे नॉट बी एप्लीकेबल इन हेटेरो एसोसिएटिव सो इनपुट में भी m sorry n and output में भी some different number m which are not equal. So again weight determination is done by Hebb's rule which uh, I just taught you in the beginning of this subject. Almost, I think, second neural network we studied, Hebbian learning. Okay, so it will find output vector which corresponds to an input vector x that may be either one of the stored patterns or a new pattern. Okay? So this is just introduction. No need to take down these points just to understand what is heteroassociative. Yes, but if in exam somebody asks you for 2 marks, write a note on heteroassociative, then you can explain this in 2 marks. Otherwise, this is not required. This is just for introduction. Okay. What is required is from this part. So the architecture is here. There are inputs x1 to xn and outputs y1 to ym where m may or may not be equal to n. Clear? This is a very important condition because input and the output patterns are quite different. Okay? So हम लोग क्या करेंगे इसको ट्रेन करते टाइम जो भी अपने पास इनपुट पैटर्न है और उनके करस्पॉन्डिंग टारगेट पैटर्न से वो देख के इसको ट्रेन करेंगे ये वेट्स को क्लियर एंड देन विल सी अगर मैंने कोई अलग इनपुट पैटर्न दिया तो इधर इज एबल टू जनरेट द रिक्वायर्ड आउटपुट दैट विल बी द पर्पस ऑफ दिस network. Yep. So you can take down the architecture. When you are taking down this,
Yes, sir.
so write the title heteroassociative memories. Second type heteroassociative memories, and then you write first one. Sorry, A architecture.
Okay, sir. Done, sir.
Okay.
So this architecture basically looks like a simple linear regression only, where we are giving the inputs and we are finding the outputs, and then we are sort of formulating the algorithm to find the values for the future inputs.
More than linear regression, you can consider it is very close to the classification problem. Regression में क्या होता है? See, I'll tell you why it is different from regression. Regression में finally whatever we get, हम लोग input का continuous values देते. Clear? We give continuous values of input, and at any input, it is able to generate a unique output. Do you agree?
Yes, sir.
इसके अंदर क्या होता है? I have a certain range of errors which is acceptable, and all are going to map to a same value.
Okay.
But it is so it is uh, not a regression problem. Regression मतलब इन सबका एक unique value I am going to fit.
Okay, sir.
Got it?
Yes, sir. Yes, sir.
Yeah. So it is like simplest language you can call it as memory. Only you don't give addresses. You give a pattern and you get output.
Okay, sir.
Got it?
Yes, sir.
Okay. So you want to take the points or you're going to capture it from the slides?
I took the screenshot, sir. I'll
Okay,
jot.
don't waste your memory. I will put it on your team.
Oh, okay, sir.
Because it will clutter your phone unnecessarily.
Yes, sir.
So
Thank you,
you
sir.
understood this architecture, right?
Yes, yes, yes.
Okay. So training algorithm, if somebody asks you, directly you can put the same training algorithm as the auto associative what we just I don't know. You were there that time?
Mm, no, sir. Actually, I was not there
Yeah,
that
yeah.
time.
So if somebody asks you training algorithm for hetero associative network, can this one or Hebb's rule you can give directly. Hebb's rule का जो flow chart है, that is applicable for auto associative as well as hetero associative memories. Okay.
Okay, okay, sir. I got it.
Yeah. Just go through it. 1 minute.
Yes, sir. Sir, I think you changed the slide. Yes. Okay, sir, got it.
Varun, just a minute. I will be back. Huh?
Okay, sir.
Am I audible?
Yes, sir.
So moving ahead to the problem of heteroassociative memories. Yeah. So we are given we have to train a heteroassociative memory using the Hebb's rule. Yep. For storing these patterns S1, S2, S3, S4. Yep. So these are the four patterns, and they have four features, and these are the corresponding target vectors. Yeah. So take down the question. Let me know once you've taken down. So I will show you the solution.
Done, sir.
So moving to the solution. So we assume all initial weights to be zero. Since we are asked for using the Hebbian rule, so we need to assume the इनिशियल वेट्स। अगर हेबियन रूल नहीं दिया रहेगा तो पिछले जो ऑटो एसोसिएटिव का मैट्रिक्स का मेथड था दैट वी कैन यूज, बट सिंस इट इज गिवन एज हेबियन रूल we need to go with same rule here. So this is the first pattern, the source pattern and the target. So we update the weights using the Hebbian learning formula. Wij new is equal to Wij old plus product of input and output here. So I hope this network structure is a bit clear. There are four inputs and there are two outputs here, and there will be corresponding weights associated with each of them. Are you able to understand?
Yes, sir. Understood.
So each and every weight we have to use Hebbian learning. But if
Okay.
you are not able to get the directly jump here, somewhere in the rough you can draw this architecture. First you should know what are the number of inputs and what are number of outputs. Then you'll get the outputs. इसके चार और इसके चार मतलब 8 weights will be there.
Yes, sir.
So, so W11 will be W11 old, which is already taken as 0, and X1 into Y1. So this is X1, X2, X3, X4. This is Y1 and Y2. Okay, so each weights corresponding मतलब इसका और इसके बीच में का weight रहेगा तो इन दोनों को मल्टीप्लाई करेगा X1 Y1. Substitute the values. Similarly, we do for W21, W31. So W21 मतलब ये और ये, W31 मतलब ये और ये, and W41 will also be there. W41 means this and this. Yeah. Similarly, now we will go for weights corresponding to second output. Again, इसको सबके साथ multiply करेंगे सब inputs के साथ. To get the weights. Are you able to understand this?
Yes, sir.
Okay, good. So now for the second input pair, which is the second pattern, we will update the weights using the same method here. So now we have taken it directly. You can do the calculations because uh, the calculations will be same. सिर्फ इसके लिए जो ये old weights रहेगा, will be this. Got it?
Oh, okay, sir. So,
So
sir, for the second input, when we consider the first weight, we will not take the latest weight that of
latest,
four.
this is the latest, no? Updated weight after first pattern.
Okay, okay, okay,
W old will be 1
okay, sir.
plus xi is this and yi will be corresponding output. So पहला weight will be मतलब W11 will be 1 plus 1 into 1 equal to 2. Got it?
Yes, sir. Got it.
So we are written directly in matrix form. ये मैट्रिक्स फॉर्म में W11, W12, W ये सब फर्स्ट इनपुट के वेट्स रहेंगे एंड ये सब सेकेंड आउटपुट यूनिट के वेट्स रहेंगे. Got it?
Yes, sir.
So मैट्रिक्स फॉर्म में जब वेट्स लिखते हैं हर एक न्यूरॉन का एक एक कॉलम होता है, हर एक आउटपुट न्यूरॉन का वेट्स का एक एक कॉलम होगा. मतलब सपोज वी हैव फोर आउटपुट न्यूरॉन्स, सो वील हैव फोर कॉलम्स इन द मैट्रिक्स. Got it?
Yes, sir.
So you can first check down this for first pattern. It is a bit lengthy but not very difficult.
Yes, sir.
You can take down and do for second pattern as well.
Okay, sir.
Yes.
Done, sir. So for the second input, the output is the first column output is coming 2011, and
Correct.
the next column is 0000.
Correct. This one you can see on the screen, right?
Yes, sir.
So after the third, now you can, if you are perfect with the problems, then you can take down these vectors directly. Okay.
Yes, sir.
And after fourth, you get this. Yep. Rather, ये तुमने वेक्टर फॉर्म में लिखा क्या पहला वाला वेट्स पहला पेयर का
Yes, sir.
जिसका W1 will be 1 0 1 0 and
Uh,
0 0
correct.
0 0. ओके,
Yes, sir.
इसको W1 बोलो तुमने जो लिखा रहेगा. सेकंड वाले को W2 बोलो. You call it as W2, W3, and this as W4. Or finally, you write W is equal to W1 plus W2 plus W3 plus W4, and then you write this step. Okay.
Okay, sir.
Oh, sorry. No, no, it's not separately. Huh? No, no, you don't write W1, W2, W. Means we are not taken individual patterns, right? We have taken every time the new weights of earlier as old weights of next one. So we accommodate. It's not W1, W2, W3.
It's for
This
each
will be
new pattern.
yeah each pattern, but each pattern के लिए अलग weight रहेगा तो क्या करते हैं? If you are taken for each S into T transpose, got it? और S transpose into T लिया रहेगा तो हर एक का अलग अलग आएगा W1 W2. इधर हमने ऐसा नहीं किया है. For each new calculation, previous वाले का new we have taken as old. Got it?
Yes, sir.
मतलब मैंने पहला पैटर्न का जो न्यू वेट्स आया था उसको मैंने सेकेंड पैटर्न का ओल्ड वेट्स लिया है. Got it?
Correct, sir.
So अगर W1 W2 करना है तो it should be S into S transpose into T हर एक पैटर्न का and then I have to add it. Is it clear? जो हमने पहले प्रॉब्लम में किया है लास्ट में एसोसिएटिव मेमोरी का.
Okay, sir.
So this is your final weight matrix. That's all. Okay.
Okay, sir.
Now let's try to uh, design the network. जो weight matrix आया, you have to draw that and mark them accordingly. Got it?
Yes, sir.
So please draw the network.
Yes, sir.
So here one more additional अंडरस्टैंडिंग यू गेट कि जो भी तुम्हारा वेट मैट्रिक्स रहता है उसका जो साइज रहता है दैट इज इनपुट बाय आउटपुट. व्हाट इट
Yes,
मतलब
sir.
चार इनपुट्स रहेंगे तो इसका नंबर ऑफ रोज विल बी 4 एंड दो आउटपुट्स रहेंगे तो नंबर ऑफ कॉलम्स विल बी 2. ओके.
Correct. Yes, sir. Done, sir.
Okay. Another problem, let us try to solve. We have to store the network. Here you see outer product rule is given. So now our life will be a bit simpler. Okay, because we don't have to use that formula repeatedly like Hebs rule. Yeah. So same format the question is. The data is different. Yeah. You know, कभी कभी एग्जाम में ऐसे भी देते हैं S1 is 1000 and T1 is 01. S1 is S2 is 0011 and T2 is 10. ऐसे भी देते हैं. Okay, so you should understand, or you can put this in this table form if at all question is given like this. Got it?
Yes, sir.
Done?
Yes, sir.
Okay. So let's see the solution here. So when we use outer product tool, we can directly use the matrix multiplication S transpose into T. Yeah. So for first sample, this is your S and this is your T. Are you able to understand what is being done?
Yes, sir.
ये पहला सैंपल उसका ट्रांसपोज उसका
Tag.
टारगेट दूसरा सैंपल उसका टारगेट yeah.
Yes.
So all for all we will go on adding. Is it clear?
Yes, sir.
That's why I told you means Heb's rule is a bit uh, difficult means lengthier to solve. But if in exam you are not given what to use, you can directly go for outer product. Got it?
Yes, sir.
You multiply this and you will get a final weight. Okay?
Yes, sir.
So it is as simple as this, right?
Yes, sir.
You can try without having a look at screen. You can try to do.
Okay, sir. I'll try.
Yeah.
Done, sir. So it's 0012 and 2100.
Hello, you are able to do this?
Yes, sir.
The network and let me know.
Done, sir.
That's right. The special case of heteroassociative networks is a bidirectional associative memory. You what we can do in this BAM is I can give the key pattern. Yep, I can give a key pattern to this network and it generates a response pattern which is different from the key pattern. Okay? So when key pattern and response pattern are not equal, we say this is heteroassociative, right?
Yes, sir.
Now this can work the reverse way also. I can give this response pattern and it will generate key pattern for me. Means it works in both direction. It can take the key pattern and generate a response pattern, or it can get a response pattern and generate a key pattern. That's why it is called as BAM. Is it clear concept?
Yes, sir.
So architecture wise, architecture will be exactly similar to heteroassociative, nothing different. Yeah. So there are two layers connected by bits. Network iterates by sending signals back and forth. मतलब आगे from input to output as well as from output to input between two layers till there is a equilibrium. मतलब I can do both kind of tasks till that it iterates. Bits are bidirectional and can corresponding to inputs in either layer that I told you. And normal architecture wise, there are n units in the input and m in the output, where n may not be equal to m because it is a type of heteroassociation. Yep, very important thing. जब भी हम लोग इनपुट साइड से आउटपुट साइड जा रहे then take weights as w and when we come another way then we take as w transpose. That's only the difference. Is it clear?
Okay, sir. Got it.
Yeah. So you're taking this or should go to the problem?
Uh, I guess we can directly go to the problem, sir. It's okay.
But after this, you people take the this one also. मतलब theory पढ़ो थोड़ा इधर से.
Yes. Yes, sir.
Just a minute. Just a minute. I think the slide has been misplaced somewhere. Okay. I will. I think I missed that slide. -1 1. I will give you the problem. Am I audible? Am I audible?
Yes, sir.
Voice. Yeah. Now I think it is better. -1 1 and 1. Is my whiteboard visible?
Yes, sir. It's visible, sir.
Okay. So you take down the question. I will tell you. Uh, the construct and test. You're taking it down, right?
Yes, sir.
Construct and test a BAM network. BAM network to associate letters to associate letters capital E and F
Yes, sir. Done.
Did you do it? Construct a BAM to associate the letters capital E and F
Yes,
with
sir.
simple input output vectors with simple bipolar input output vectors. Continue. The target output for E, the target output for E is minus 1, 1. The target output for E is minus 1, 1. And for F is 1, 1.
Yes, sir.
The display matrix is 5 by 5. The display matrix is 5 by 5. And these patterns are as follows. Check whether I can draw this on whiteboard. Okay, anyways, you can change slide as well. Write on the slide because whiteboard is difficult to write.
So, actually, I cannot see any changes that you're
Yeah,
making
yeah.
on.
I'll stop that. Hmm. Stop the slide. Yeah. Um, can you help me out with the question? Question is
Yes, sir. Construct and test
construct and test
a BAM network
BAM network.
to associate letters E and F
Associate letters E and F
with simple bipolar input output vectors
with simple bipolar input output vectors.
comma the target output for E is equal to minus 1 1.
Target output for E is minus 1, 1, right?
For F is 1 and 1.
For F is 1, 1.
The display matrix is 5 cross 5 in this pattern, which is as follows.
The display matrix is 5 cross 5, 5 cross 3 you make it.
Oh, okay, sir.
And pattern is as follows. Okay, the pattern is something like this. P dot. It's actually star. And there is star dot. There is star star star. It's fine, right? Yeah. And for if it is dot and dot. This is the E and this is the F. Got it?
Yes, sir.
It for E is given as minus. And taken down the
Uh,
pattern.
yes, sir. Done.
Okay. Now in earlier classes we have came across this type of problem. Do you remember this? ऐसा है तो इसका ट्रेनिंग वेक्टर कैसे बनाने का we had done.
Yes, sir.
What we do? Any idea about it?
Uh, I don't recall the methodology exactly, sir, but I remember that we have come across something similar to segregate
Okay, no
the.
problem. Yeah. So first I will.
So we solved it using perceptron method. I think.
Correct, correct, correct. So now you come to the solution. First thing is that you have to unroll that pattern and convert it into single vector. Okay.
Okay, sir.
Input pattern is given to you. That input pattern is first is E and second one is F. And second we have been given as we convert that into pattern clear inputs. So E के अंदर पहला तीन स्टार है. So I'll call stars as 1 1 1. And in the second row there is first star and then two dots. In the third row again there are all stars. So 1 1 and 1. In the fourth row again there is first star then two zeros. And in the last row again it is all stars. Did you get this?
Yes, sir.
This is my pattern for E. You add one more column here. Targets. Target क्या है?
-1 and 1.
-1 and 1. Good. So for F, what you have done is 1 1 1 again 1 1 1 then 1 -1 -1 then again 1 -1 -1 and 1 -1 -1. Here
Yes, sir.
target is 1 1 I
Wha-
guess, right?
Yes, sir.
Yeah. So this is given to us. Now to find the weight vector, what we do? W is equal to formula S transpose into T,
Target matrix.
correct?
Yes, sir.
Summation. So for iteration, we use the variable P. Okay, this is our P. So पहले you take this one S transpose into T, then you take S transpose into T, and you will get two W's, right?
Yes, sir.
You get S1 transpose into T1 plus S2 transpose into T2, correct?
Yes, sir.
Can you do this for me?
Yes, sir. Just a minute, sir. I'll solve it.
Yeah. Do it patiently. Don't be in hurry.
Yes, sir. So you want the final W, the summation, right? Or
Yes,
both?
yes.
Yes.
Okay, I will tell you if you want to verify the answer. Let me just tell you. What one answer?
No, sir. I am working on the second matrix
Okay.
multiplication. I got it, sir.
Yeah.
So the
I will
first,
read out column wise.
yes, sir. I'll read out
Just
column wise.
okay. You are reading. Okay, go ahead.
Uh, the first column is 0, 0, 0, 0, 2,
You
2,
are telling me final or
final, final, sir.
okay. Okay, go ahead. Tell me.
0, 0, 0, 0,
Yeah.
2, 2, 0, minus 2, minus 2, 0, 0, 0, 0, minus 2, minus 2. This is the first
Correct.
column. And the second column is 2, 2, 2, 2, 0,
Yeah.
0, 2, 0, 0, 2, minus
Yeah.
2, minus 2, 2, 0, 0.
Correct. Your weight matrix is absolutely correct. Got it? How to
Yes, sir.
calculate?
Yes, sir.
Yeah. Now, what we need to do is verify whether this network was able to memorize that pattern. So you write the title, uh, verifying for training inputs or testing for training inputs. Okay. So for obtaining for first pattern, what you're going to do, y in 1 is equal to x1 into w. Got it?
Yes, sir.
तो x1 जो है तुम्हारा ये मैट्रिक्स दिस यू टू मल्टीप्लाई विथ व्हाट w you got just now. सेम सेकंड के लिए करना है. सेकंड के लिए you leave the space and do as homework, but one you do. Okay?
Okay, sir.
Yeah. It's a big matrix multiplication, but finally what you are going to get is a small vector only two places. I hope you understand. You'll get vector of this form.
Yes, sir.
Yeah.
So I'm getting minus 12 and 18.
Okay, minus 12 and 18.
Yes,
Apply
sir.
the activation function. What it gets converted into?
Uh,
Apply activation function. And what you get? You got minus 12 and
18, sir.
18. So somewhere you need to mention the activation function, which you missed out. Your activation function is same. F of x is equal to 1 when x is greater than 0 and minus 1 when x is less than equal to 0. Got it?
Yes, sir.
Somewhere please mention this. And now after this you write applying activation function 1. What we get? Y1 is equal to minus 1 1, correct?
Yes, sir.
Means first pattern it was able to reconstruct. Got it?
Yes, sir.
अभी what you write for second pattern और इसके लिए जितना जगह लगा उतना जगह छोड़ दो. Leave that much space.
Yes, sir.
So you can try when you are fresh and have motivation to do this one.
Yes, sir.
So ये BAM है ना तो हमने फॉरवर्ड पास चेक कर लिया. Now we have to check the reverse pass. Got it?
Yes, sir.
So you write testing network or input from Y side. Y मतलब आउटपुट साइड. ठीक है, लेकिन अब हम लोग उनको आउटपुट नहीं बोलेंगे क्योंकि आउटपुट का मतलब अभी आउटपुट अपने इनपुट साइड में आने वाला है. गॉट इट?
Yes, sir.
यस. यू से फॉर फर्स्ट और फर्स्ट पैटर्न.
We'll take the transpose and multiply by the weight.
यस. सो y in is equal to it will be x. x तुम्हारा भी ये रहेगा. दिस विल बी योर x. ये सेकंड के लिए करो. यू डू इट फॉर सेकंड. फर्स्ट का हमने फॉरवर्ड चेक कर लिया ना.
Yes,
फॉर
sir.
सेकंड x डॉट w ट्रांसपोज. इज इट क्लियर? तुम्हारा w was I think 15 by 2, right?
Yes, sir.
अब ये 2 by 15 का रहेगा. ये वाला ये ऐसा हॉरिजॉन्टल बढ़ाएगा.
Correct, sir.
एंड दिस x इज दिस वन. तो इसमें कभी सॉरी ये वाला दूसरा कर रहे हैं ना. तो इसमें कभी मिस्टेक आया ना तो इमीडिएटली समझ में आता है. द मैट्रिक्स डायमेंशंस डोंट मैच.
This dimension will be 2 by 15, sir. Correct?
यस दिस इज 2 by
By
15
15.
और इसको 2 by 15 ही होना चाहिए क्योंकि इसका डायमेंशन कितना है? 1 by 2. करेक्ट?
Yes, sir.
दिस नंबर्स हैज टू मैच, राइट?
Yes, 2 by 15.
And once you solve you will get 1 by 15. Is it clear?
Uh,
ये देखो इसको मल्टीप्लाई करोगे 1/2 और 2/15 तो तुम्हारा आउटपुट मैट्रिक्स इज ऑलवेज these two numbers.
1 by 15. Okay, sir.
Got it?
Okay, okay, sir. Got it.
और 1/15 मतलब तुमको ये पैटर्न मिलेगा आफ्टर अप्लाइंग एक्टिवेशन फंक्शन.
Yes, sir.
तो ट्राई आउट. इसमें भी फर्स्ट पैटर्न का जो वेरिफिकेशन है यू डू एज अ होमवर्क. मतलब एक फॉरवर्ड पैटर्न का और एक बैकवर्ड पैटर्न का यू कैन ट्राई एट योर होम फॉर प्रैक्टिस. ओके.
Okay, sir.
ये सॉल्व करो एंड लेट अस सी.
Yes. Done, sir.
Okay, what is the matrix you are getting?
2, 2, 2, 2, 2, 2, 2,
How
minus
many
2,
times 2?
1, 2, 3, 4, 6, 7 times 2, then
Okay.
minus 2, minus 2,
Hmm.
2, then
Okay.
1, then minus 2, minus 2,
Minus 2 minus 2.
2,
Okay.
and again minus 2, minus 2.
7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now you apply activation function, which is in equation number 1. We get y is equal to 2 is greater than 0. So 7 times 1, 4, 5, 6, 7. And after that, 2 times minus 1, then 1, then 2 times minus 1, then 1, then 2 times minus 1. This is same as this pattern, right?
Yes, sir.
So I can give input to the network in either direction and I get the other side of the network. Got it?
Yes, sir. Got it.
Yeah. Then you, for first pattern you keep the space, okay?
Yes, sir.
Okay. And finally, what you are going to do, the network you are going to draw. You have calculated the weight matrix, right?
Yes, sir.
Finally, you draw the network. कितना inputs है इसका? 15 inputs. Okay. And then two outputs and the connections.
Yes, sir. Got it.
Yeah. So first draw the network. Actually, I had a slide, but I don't know. Actually, it got deleted. So all the three types of associative memories are clear. Auto-associative, hetero-associative, bidirectional associative.
Yes, sir. Done, sir.
So we'll take a break of 5 minutes. But you want a longer break?
No, sir. That's all right.
5 minutes we'll take a break. You also get fresh. And then I will introduce the Hopfield network and then we'll stop. Problem is solved next time. Okay.
Okay, sir.
Yeah. Are you back, Varun?
Yes, sir, I'm here.
Okay. So I will introduce you the Hopfield network, and then we'll stop. We'll not solve problem today. Okay.
Okay, sir.
So it is a auto-associative network only, but difference is that is feedback. अभी तक जो network देखा था उसके अंदर we never had feedback from output to input, right?
Yes, sir.
Yeah. So discrete Hopfield network जो auto-associative का special case है, where there is feedback. So we call it as recurrent network. So discrete Hopfield network is a type of recurrent network. Yeah. So the recurrent architecture, as I told you, it takes either binary inputs or bipolar inputs. But normally, as usual, bipolar inputs makes it easy for network to generalize and for us to analyze. Here, their weights are symmetrical and very important. No self connection. मतलब तुम्हारा जो आउटपुट नेटवर्क रहेगा उसका इनपुट्स विल बी देयर एंड हर एक नेटवर्क का आउटपुट विल बी फेड बैक एज अ इनपुट टू ऑल द न्यूरॉन्स बट खुद का फीडबैक खुद को इनपुट नहीं आएगा मीन्स ये फर्स्ट का आउटपुट है इट विल कम एज इनपुट टू other two but not its own. This connection won't be there. Is it clear?
Yes, sir.
Yeah. So Wij is equal to Wji. This is called as symmetry, and Wii is equal to 0. It is no self connection. At a time, only one unit updates its weight. Each unit continuously receives the input signal, that is, extra signal is input with other units output. Clear?
Yes,
When
sir.
performing a sequential update process, input pattern पहले देते हैं. First input pattern is applied to the network and output is initialized accordingly. Clear? तो पहले we assume that input में जो pattern है वही output है. फिर feedback ले लेके we continuously update. So this point will be more clear when we solve the problem. So once the network starts, initializing pattern is removed and output is initialized becomes a new updated input through the feedback connections. First input forces first updated output, which in turn acts as second updated input to the feedback. मतलब मैं जब भी first input देता हूँ तो I get a first output और ये first output will serve as input for second iteration. That's what is explained here. So this continues until weight updation stops. Weight नहीं change होंगे and we say network is equilibrium till that this process continues. Feedback, weight updation, feedback, weight updation. This way it continues. Take some time, read through these points. No need to copy. It's just introduction. Just quickly go through.
Okay, sir. Yes, sir, done.
Okay. So architecture, will show first architecture, then it will be better. See, when you see the architecture, very important. See here, ये ब्लू कलर का जो फीडबैक आया है, ये खुद को कनेक्ट नहीं हुआ है. Can you see it?
Yes, sir.
हर एक का output comes, it doesn't get connected to its own input, but it goes to other outputs. That's very important. And second, feedback है, हम इसको बोलते हैं recurrent. Okay? And there is no feedback to own neuron, so it is called as without self connection. Is it clear?
Yes, sir.
Okay. So first you take down this diagram, architecture.
Yes.
Title लिखा discrete output network.
Yes, sir. Sir, according to
Ah
the
yes.
description, the
Ah
when the output is initialized, the feedback becomes the input for the other networks.
correct.
So, sir, it becomes the input for all the networks like this. The networks can have multiple inputs, right? For Y1, the input will go to Y2, Y till Yn. Y2, it will
Yes.
go to Y1 and Yn.
Yes. 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 Correct. Means सिर्फ वो खुद को नहीं जाएगा, बाकी everyone it can go.
Okay, okay, sir.
Only own feedback. See, ये रेड वाला भी जो Y2 आया है, इसका रेड से Y2 को कनेक्शन नहीं है. बाकी N networks को है. This is N, right?
Yes.
All
So
N connections will be there except
e-
own.
each and every output will have multiple inputs. Like Y1 will have inputs from Y2, Y3, Y4, and till Yn.
Yes, yes, yes.
Oh, okay, sir.
Plus the external input.
Yes. Done, sir.
And all these points will be more better when you means the important thing about neural networks is that when you solve the problem, you get a better understanding of the algorithm. Okay.
Yes, sir.
Okay. So architecture wise, we have done already the figure. There are processing elements with two inputs, one inverting and one non-inverting. Clear? मतलब what we have not written here is that ये जो y1 रहता है इसका कॉम्प्लीमेंट इज ऑल्सो अवेलेबल विथ अस. कॉम्प्लीमेंट मतलब नेगेटिव, मतलब ये वन रहेगा तो ये तो -1 रहेगा. Got it? But you are not represented in the architecture for simplicity. Is it clear?
Yes, sir.
Yeah. So there are processing elements with two outputs, one inverting and one non-inverting. Output of each processing element are fed back to the input of all other, but not to itself. Connections are resistive and connection strengths are represented by Wij. There are no negative weights. Okay. Excitatory connections use positive outputs. मतलब मैंने बोला कि हर एक न्यूरॉन का दो आउटपुट्स होता है. दिस इज y1 एंड दिस इज y1 बार. क्लियर? सो अगर ये बाकी सबको एक्साइटेटरी फीडबैक देता है, उसका वेट विल बी ऑलवेज पॉजिटिव. तो एक्साइटेशन रहेगा तो पॉजिटिव आउटपुट जाएगा, और इसको इनिबिट करने गए तो ये नेगेटिव आउटपुट जाएगा थ्रू सेम वेट. इज इट क्लियर?
Yes, sir.
Yeah. Connection between The processing elements I and J is found to be associated with the connection Wij. Means connections are represented by weights. Weight is positive if units I and J both are on, and negative if one unit I is on and J being off. Actually, not weight. Don't take this. Weight. There are no negative weights. Clear? Yeah, weights are symmetric. This is true always. मतलब W13 तुम्हारा weight रहेगा. It will be equal to W31. मतलब तुम्हारा weight matrix will be, एक तो बीच में सब जीरो रहेंगे without self connection, right? Understand
Yes,
this?
yes, sir.
And ये जो triangular elements रहेंगे, they will be corresponding to this triangular because all Wij's equal to Wj's. Clear?
Correct. Correct. Yes.
So you can take down these points after lecture from the lecture notes which I will put. Clear?
Okay, sir.
So training algorithm for storing patterns S of P, where P is from 1 to capital P. We have a vector S of P having all the n patterns. The weight matrix is given by this formula. Clear? For I not is equal to J, because you know that for I is equal to J, what will be weight? 0. Correct? Self feedback is not there.
Yes, sir.
Yeah. ये बाइनरी पैटर्न दिया रहेगा. वेट्स आर ऑलवेज बाइपोलर. क्लियर? सो इसको हम लोग को बाइपोलर में कन्वर्ट करना है. तो दिस इज द फॉर्मूला फॉर कन्वर्टिंग बाइनरी टू बाइपोलर. इज इट क्लियर?
Yes, sir.
एंड अगर तुमको पैटर्न्स बाइपोलर फॉर्म में दिया है तो डायरेक्टली यू कैन मल्टीप्लाई. ओके?
Got it, sir.
No self connection. So Wij is equal to 0 or I is equal to J. That's it. Clear? You can take down this algorithm and then we'll stop for the day.
Okay, sir.
Yeah.
Sir, do you have any example in some based on this?
This problem you are saying?
Yes, sir.
Yes, yes, we have no.
Uh, Sir, if it's okay with you, maybe we can do one problem so I'll
Yes,
maybe
yes, yes, yes.
understand better.
I was, yeah, yeah. If you're ready, we'll do it. No worries.
Yes, sir. Thank you, sir.
Okay, done with this?
Yes, sir. Yeah.
Okay. We'll go ahead with problem. No worries. I thought you will become saturated, so I was telling.
No, sir. I think I'll understand better if we do one
Correct.
problem.
Correct. We'll go ahead. No worries. So take down the problem. We have to construct. I hope you got it. Discrete Hopfield network is a type of associated network. Okay, auto-associated network.
Yes, sir.
To construct an auto-associated network using discrete Hopfield net architecture, we have to store this vector. Okay, this vector is to be stored, and then we have to test as usual with missing entries and second component of the stored vector. Clear? मतलब second component मतलब इसको we have to test with uh, missing entry. Suppose this becomes 0, तो क्या होगा? We have to understand. Is it clear?
Yes, sir.
Take down the question. Then we will start.
Yes.
Done?
Yes, sir. Done.
Okay. So let's go ahead to solve this problem. So input vector we'll assume it to be x, variable x. The weight matrix normal like our regular problem which we solved S transpose into T. This is known to you, right?
Yes, sir.
Yeah. So we'll simply substitute and we get this as our weight matrix. Is it clear?
Yes, sir.
Okay. Now, since this is very important step in discrete Hopfield network, no self connection. मतलब ये सब जो terms है, इनको we have to make it 0. Okay.
Yes,
And
sir.
it will always be a square matrix because इसका और इसका dimension same क्योंकि both are same. Got it?
Yes, sir.
Yeah. So making all the diagonal elements, I get WH. This weight matrix is my final weight matrix of free network. This please mark this step as very important. So normally we are in mode of auto-associated networks, and we tend to keep this as same as it is. Okay?
Yes, sir.
Yeah. So now testing the network for the given input, we'll convert that into बाइनरी. क्लियर? ये जो है इसको बाइनरी में कन्वर्ट कर दिया, -1 को 0 कर दिया. Got it?
Yes, sir.
So we have to carry out asynchronous updation क्योंकि हम लोग ने बोला है कि at a time only one unit will be updated, right?
Yes, yes, sir.
Yeah. So iteration number 1, testing network with missing entries in first and second place. While activation function as usual, we take this binary activation function. Weight matrix is known to us. Input vector missing entries at first and second place, right? These two are missing entries. We made it 0. Is it
Yes.
clear till this point?
Yes, sir.
Yeah. अभी first time हम लोग क्या करते हैं? We set output as input, means our x becomes our y. Clear?
Yes, yes, sir.
Okay. After that, any one unit, मतलब अपने पास कितने आउटपुट है अभी? 4 आउटपुट है, राइट? 4 नेटवर्क्स, 4
Yes,
न्यूरॉन्स. तो किसी एक को सिलेक्ट कर सकते हैं. वी हैव सिलेक्टेड y1. ओके.
yes, sir.
तो y in 1 जो रहेगा, मतलब इसके जो इनपुट्स आने वाले हैं, दैट विल बी इसका खुद का इनपुट प्लस weighted inputs of all other neurons. Got it?
Oh, okay, sir. Understood.
समझा क्या?
Yes, sir.
Okay. So it will be 0 क्योंकि इनपुट में फर्स्ट पैटर्न 0 है ना. It is,
Yes.
yeah, 0 plus y अपना सेम एज इनपुट है. We are taken for first iteration same as input.
Yes, sir.
करेक्ट. एंड w j1 मतलब फर्स्ट न्यूरॉन वेट मैट्रिक्स का फर्स्ट कॉलम. गॉट इट?
Oh, uh,
हम लोग पहले न्यूरॉन इसको अपडेट कर रहे हैं ना, इसको, बराबर.
yes, sir.
तो इसके अंदर आने वाले सारे वेट्स ऐड होंगे.
Correct.
तो इसके अंदर आने वाले वेट मतलब फर्स्ट कॉलम.
Correct. Correct, sir.
गॉट इट?
Yes, sir.
और इस फीडबैक का टेंशन नहीं लेने का क्योंकि हम लोग ने ऑलरेडी इसको 0 कर दिया.
Uh, how does that?
यस, वेट. यू गॉट दिस वेट मैट्रिक्स करेक्ट?
Yes, sir.
ये वेट मैट्रिक्स ऐसा है कि तुम्हारा 4 न्यूरॉन्स है. ओके.
Yes, sir.
हर एक को एक इनपुट आया है फ्रॉम आउटसाइड जो हम लोग का पैटर्न है x1 x2 x3 x4. क्लियर?
Yes, sir.
देयर आर नो वेट्स फॉर एक्सटर्नल इनपुट्स. लेकिन अभी मैं सिर्फ इसकी बात करूंगा फर्स्ट न्यूरॉन. इसको इधर से इनपुट आया है, इधर से इनपुट आया है और इधर से इनपुट आया है, बराबर.
Yes, sir.
ये वेट क्या रहेगा? W21.
Correct.
ये वेट क्या रहेगा? W31.
Yes, sir.
एंड ये वेट विल बी W41.
Oh,
डू यू एग्री?
yes, sir.
वी W और पहला वाला W11 will be 0. Self connection 0 है, बराबर.
Yes, sir.
So if you see in the matrix, what is this position?
W11,
What is this position?
W12,
हाँ,
two
row
one,
number and column number, right?
yeah, 21,
This is,
W31,
this is.
W41.
मतलब
Okay.
मुझे अगर इसका weights अपडेट करना है, weight चाहिए, तो फर्स्ट कॉलम इज इसका weights,
Yes, sir. Understood.
दूसरा कॉलम इसका weights, बराबर.
Yes, sir. Now I got it.
यस. एंड खुद का सेल्फ कनेक्शन 0 है तो हमने ऑलरेडी इसको 0 कर दिया विदाउट सेल्फ कनेक्शन में.
Yes, sir.
क्लियर नाउ?
Yes, sir. Clear.
तो जब भी हम y1 अपडेट करेंगे तो ये लेंगे, y2 अपडेट करेंगे तो ये वाला, y3 अपडेट करेंगे तो ये वेट, और y4 जब अपडेट करना है तब ये.
Yes, sir.
क्लियर?
Yes, sir.
गुड. सो आई हैव टेकन द फर्स्ट कॉलम ऑफ द वेट मैट्रिक्स. क्लियर?
Yes, sir. Now clear.
Good. And then I multiply and I get it as 1. Applying activation function greater than 0 है तो it will remain as 1. Clear?
Yes, sir.
अभी मेरा पहला इनपुट वेक्टर ये था, बराबर. 0 0 1 0 था, बराबर.
Yes, sir.
इसका जो फाइनल y1 आया है उससे ये पोजीशन को रिप्लेस करेगा. इट विल बिकम नाउ 1 0 1 0 एंड दिस विल बी नेक्स्ट वेक्टर. हम लोग नॉर्मली वेट वेक्टर्स को अपडेट करते हैं. वेट ऑलरेडी इसका हो गया है. अभी मुझे एक आउटपुट निकालने के लिए पहले इसको, फिर इसको, फिर इसको, फिर इसको ऐसे अपडेट करते जाना पड़ेगा एंड देन आई गेट अ फाइनल आउटपुट. क्लियर?
Yes, yes, sir.
मैंने अभी जो किया वो सिर्फ किसके लिए किया है? फर्स्ट
Y1.
वाले के लिए. और वो जो भी आया इमीडिएटली उसको अपडेट करने का. दिस इज न्यू वन. क्लियर?
Yes, sir.
ओके. नो कन्वर्जेंस क्यों लिखा है मैंने? बिकॉज इट इज नॉट सिमिलर टू द पैटर्न विच आई टोल्ड.
Correct, sir.
क्लियर?
Yes, sir.
ओके. नाउ आई विल से आई हैव चोजन y4 फॉर अपडेशन. कोई भी आई कैन गो इन एनी ऑर्डर. ओके. मैंने पहले y1 लिया फिर y4 लिया. ओके.
Yes, sir.
तो सेम यही फॉर्मूला, ओनली दिस विल बी 4.
Correct, sir.
अभी मैं कौन सा कॉलम लूंगा वेट मैट्रिक्स का इधर इसके लिए?
The fourth column.
फोर्थ कॉलम. गुड. सो दिस फोर्थ कॉलम आई हैव टेकन. ओके.
Yes, sir.
And I will apply equation function and I get this as 0. अभी मैं ये तो ऑलरेडी y1 के से अपडेट हुआ था, ये चेंज नहीं हुआ, बट इफ इट इज गेट चेंज आई विल रिप्लेस दैट। क्लियर?
Okay, sir. Only if it gets changed, we replaced it. We don't.
मतलब जो भी रहेगा डायरेक्टली इधर डाल देने का। अभी इधर
Okay,
जीरो आया है तो देर इज नो चेंज।
okay, okay, sir. Got it.
इधर चेंज हुआ है, देखो इधर वन आया था।
Yes, sir.
ओके,
Yes, sir.
देन मूविंग अहेड, वी चूज y3 फॉर अपडेशन बिकॉज वी आर मूविंग रैंडमली। तो थर्ड कॉलम लेगा मैं, और ये लेटेस्ट y लेने का।
Yes, sir.
ये
So,
टू
sir,
आया। हाँ
if
बोलो।
even if we move randomly, the values of y won't affect
नो,
like.
दैट्स अ कैरेक्टरिस्टिक, it goes randomly but it converges to same solution.
Okay.
Got it?
Yes, sir. Okay.
Yeah. So I will apply activation function and then y3 भी change नहीं हुआ, रह गया वही, मतलब y3 was 1 already, it is getting 1 only, तो जो भी है वो उधर रख देने का। ओके,
Okay, sir.
अभी एक ही बचा है, y2। So we'll take y2, second column of the weight matrix and then applying activation function, वो 1 हो गया।
Okay, sir.
Okay, so
Yeah.
do you agree that this is similar to one we had stored?
Yes, sir. So this proves that even going randomly, the values is still staying same, so it is not affecting in any manner.
Yes, yes, yes. You can change the sequence and verify. You will get this H final.
Yes, sir. Understood.
Got it?
Yes, sir.
तो सिंपल स्टेप में इफ आई वांट टू समराइज, सबसे पहला वेट मैट्रिक्स फाइंड करने का, एस ट्रांसपोज इनटू टी, वेयर एस एंड टी आर सेम। ओके, ऑटो एसोसिएटिव जो वेट मैट्रिक्स मिलता है, फिर इसका डायगोनल एलिमेंट्स जीरो कर देने का। फिर मुझे जो भी पैटर्न चाहिए उसको लेने का, पहले सबसे पहले x इज इक्वल टू वाई सब्स्टिट्यूट करने का, क्योंकि पहले में अपने को y पता नहीं रहता है। ओके,
Yes, sir.
फिर करस्पॉन्डिंग एक कोई तो यूनिट सिलेक्ट करने का अपडेट करने के लिए, उसका जो x है, टिक इट, ये जो वेक्टर yj रहेगा, इट इज फॉर फर्स्ट टाइम सेम एज इनपुट वेक्टर corresponding column of the weight matrix and go on updating this y. Clear?
Yes, sir. Clear.
So I will now give you from the starting steps, so you can go ahead with the second iteration also if you want. So this is a weight matrix, the input vector is given. Second, uh, first time we take output as same as input, then choosing y for updation, applying activation function, there is no change। फिर y4 मैंने select किया, there is no change। y3 select किया, there is no change। and y2 select किया, there is no change, क्योंकि network has converged। Got it?
Yes, sir.
So now you can take down the solution. You understood it now?
Yes, sir. Now I understood it.
Good. This one. You can go ahead, go through the steps and then try to do yourself.
Done, sir. So I'll try the network on my own, sir, for the part.
You will try.
Yes, sir.
Okay. So you will able to understand if I put it on your Teams.
Yes, sir.
Should we stop?
Yes, sir.
Okay. Or if you want to take, I can wait. No problem.
No, sir. I guess I'll try it on my own, sir.
Okay. So that's all. Thank you. We'll stop for the day.
Yes. Thank you, sir.
Yeah. Welcome. You can leave, Arun.